All right, let's dive right into this explainer. Whenever we see numbers stacked on top of each other, it kind of feels like this rigid, purely academic exercise, right? But today, we're going to completely flip that script. We're going to discover how fractions aren't just abstract math, but actually a highly logical language used to describe our physical reality. We're going to look at these concepts visually to really understand how they represent everything from sharing a delicious meal to measuring the literal physical space around us.
We're starting things off with a brilliant little brain teaser from a fifth grader named Tamana, and this instantly challenges all our basic assumptions about math rules. When we look at numbers purely on paper, it's absolutely drilled into us that a half is always greater than a third. But let's bring this into the real world. Is there ever a scenario where 1/3 of a chocolate is actually a larger physical piece of food than 1/2?
Well, Tamana hits the nail on the head here. She claims her 1/3 piece of chocolate is larger than 1/2 of another, which brilliantly illustrates a core truth. The size of the original whole really matters. Imagine Tamana is holding a massive giant-sized chocolate bar and someone else is holding a tiny bite-sized chocolate square. In that case, 1/3 of that giant bar is absolutely going to be way bigger than half of the tiny square. So to compare fractions accurately, the whole that they're derived from has to be exactly the same size. Context is literally everything.
Section 1. The Sandbox, Discovering Equivalent Fractions. Let's see how we can play with different sized pieces to represent the exact same amount. Meet Gurpreet. He's exploring this exact concept with a visual fraction kit to prove that combining two 1/4 pieces perfectly matches the size of a single 1/2 piece. By just putting these pieces side by side, he makes this awesome physical discovery. When a 1/2 piece is broken down into two equal parts, each of those smaller parts is a 1/4 piece. It is the exact same amount of physical space, just chopped up a little differently.
And that brings us to a real game changer: equivalent fractions. The crucial takeaway here is that equivalent fractions might look totally different on paper, but they physically represent the exact same amount of space. They're really just different names for the same portion of a whole. Whether you say 1/2 or 2/4 or even 3/6, you are describing the exact same shaded physical region.
Now, if we look at the numbers, there's a fascinating hidden pattern. As the number of pieces multiplies, the physical size of each piece shrinks proportionally. Think about it. If we take a 1/3 piece and cut it into twice as many pieces, we get 2/6. If we cut it into 3 times as many, we get 3/9. The top number grows, the bottom number grows, but the actual value, the real estate that the fraction takes up, that remains completely unchanged.
Moving right along to Section 2, the real world, fractions greater than 1. Let's step out of the sandbox and into the dining room to tackle fractions that actually spill over a single whole unit.
Ramon's dad is making these soft, delicious parathas and cuts them into halves, which raises a pretty tasty question. What happens if someone eats more than 2 halves? We often think of fractions strictly as pieces of one single thing. But come on, hunger doesn't just magically stop at one paratha. If you eat 3 halves, you've eaten one whole paratha plus another half of a second one. If we track the family's dinner visually, it makes total sense. Eating 5 halves, or Dadaji eating 7 halves, simply pushes our total forward past a single whole paratha on the number line. It's incredibly straightforward once you actually map it out like this. 5 halves, that's just 2.5 wholes. 7 halves means Dadaji actually ate 3.5 parathas. The fractions just stack end to end to build numbers larger than 1.
We can see this exact same rule play out with everyone's favorite, pizza. If you combine 3 1/3 slices, you've perfectly rebuilt one whole pizza. Ramon's family has 6 members, and they order 2 pizzas cut into thirds. When they start trading slices around, like Dadaji and Dadaji giving their slices to Ramen, we can literally just add the thirds together. 1/3 plus 1/3 plus 1/3 equals 3/3, which visually snaps right back together, piece by piece, to form one complete whole.
All right, Section 3, the toolkit, comparing fractions. Now for the showdown. How do we easily compare any 2 fractions without getting totally lost in complicated math formulas?
You really have 2 logical paths here. If the pieces are identically sized, meaning the denominators are exactly the same, well, you just count them. The person with more pieces wins. But what if you both have exactly 4 slices, but from different pies? That's when you've got to ask yourself who has the bigger slices. Same number of pieces means you have to compare the actual piece size. Let's put this into practice. A 1/6 piece is physically smaller than a 1/5 piece, which immediately tells us that 4/6 of a paratha is less food than 4/5 of a paratha. Since a paratha cut into 6 pieces results in smaller individual parts than one cut into 5,
4 of those smaller pieces will naturally give you less food than 4 of the larger pieces. It's just pure, logical, visual comparison. But wait, what if both the top and bottom numbers are completely different? That's when we pull out our absolute smartest trick, benchmarking against simple concepts like the number 1 or 1/2. We don't always need to go through the hassle of finding a common denominator if we can just compare both fractions to an easy middle ground that we already understand perfectly. Check this out. By just comparing to a single whole, it becomes instantly obvious that 8/6 is larger than 7/8. And hey, absolutely no calculator required. Think about it. 7/8 means you have less than a whole, right? You're missing one piece to complete the set. On the flip side, 8/6 means you've got more than enough pieces to make a whole 6-piece set, plus 2 leftovers. So something larger than a whole is, for sure, always going to be bigger than something smaller than a whole. Now, let's try applying that exact same logic to the halfway mark, and we can effortlessly see why 5/8 is greater than 3/6. We know instinctively that 3 is exactly half of 6, so 3/6 sits right on the 50% line. But what about 5/8? Well, half of 8 is 4, so 4/8 would be exactly half. Since we have 5 pieces, we're holding more than half. Therefore, 5/8 easily beats 3/6.
Okay, before we wrap up, I'm going to leave you with a crawling little puzzle to test your brand new spatial skills. If every ant is exactly 1/4 of a centimeter long, and you have 16 of them marching end to end, how many holes does that build? Try applying what we've learned today to visualize the math. Because ultimately, fractions aren't just confusing numbers stacked on a page. They are the underlying architecture of how we share, measure, and truly understand the physical world around us. Keep looking for those hidden pieces of reality, and thanks for joining me on this explainer.